we're going to talk about speed, velocity, and acceleration. But in order to do that, we have to get some definitions first. So the first thing is position. The position of an object in physics is where it's located at a particular time. So, and it's always based on the origin of that object. So it's where that object is located at a particular time based on where it started. Okay? So the origin is the place where the object started. Its position is where it's at a particular time based on that origin. So right here, this girl down here, her origin was at this line. This is where she started from at 0. Okay? So her position at this time is 2 meters. Her position at this time is 3 meters. Because she's 2 meters away from the origin. Here she's 3 meters away from the origin. So that is basically her position. Now, the basically net change in her position from her origin is called displacement. So basically it's the distance that she is away from the origin. So here she's 2 meters away from the origin, so her displacement is 2. Here she's 3 meters away from the origin, so her displacement is 3. So the origin is where the object starts. Its position is where it's located at in any particular time. So there's also now distance. Distance is how far an object has traveled regardless of what direction it's going in. So here you'll notice this is the origin, 0. This is where the man started walking. Okay? His position when he's right here, he's at about 8 meters. Okay? His position if he's at the finish line, he would be at 10 meters. His position when he's right here coming back would be about 3 meters. So that's his position. It's where he's located at a particular time. His distance is how far he's gone. So when he walks all the way down here to the finish line and then walks back to this point, he'd be at about 17 meters. That would be his distance. Okay? If he goes all the way back to the origin, then his distance would be 20 meters because he walked 10 meters this way and then he turned around and came back and walked 10 meters this way. His distance would be 20 meters. His final position, though, would be 0 because he's right back where he started at the origin. Okay? So position is where he's at any particular time. Distance is how far he's gone total. So what is speed? Speed is basically the rate of change of distance over a period of time. So the word rate means a ratio, so it's how much something changes divided by how long it takes. So the speed is basically distance divided by time. It's how far you've gone or an object is gone in a certain amount of time. If something is going a constant speed, that means that that object is traveling the same amount of distance in the same amount of time. It's not speeding up. It's not slowing down. Basically, guys, constant speed you can think of as going the same speed all the time. It's not speeding up. It's not slowing down. It goes the same speed all the way through. So, for instance, speed and position. This bicycler is traveling at 1 meter per second, which means for every second that he rides, he goes 1 meter. So after the first second, he's gone 1 meter. After the second second, he's gone 2 meters. After the third second, he's gone 3 meters. He goes 1 meter every second, so 1 meter per second. After 5 seconds, or when he's at 5 seconds, his position is 5, because that's where he's at compared to the origin, which is 0. But his speed is still 1 meter per second, because if you take the distance he's traveled, 5 meters, and you divide it by the time, 5 seconds, 5 divided by 5 is 1. So he's still going 1 meter per second. This bicycler down here is traveling 3 meters per second. So every second that he travels, he goes 3 meters. So in the first second, he goes 3 meters. In the second second, he goes another 3 meters. In the third second, he goes another 3 meters. In the fourth second, he goes another 3 meters, and so on. After 5 seconds, his position would be 15 meters, because he's 15 meters away from the origin, which was 0. But his speed is still 3 meters per second, because if you take the distance he's gone, 15 meters, and you divide it by the time, 5 seconds, you get 3 meters per second. So how do we calculate speed? Again, it's distance divided by time. Total distance you've traveled, the total divided by the amount of time it took. So this car goes from the starting point here in Chicago and it ends down here somewhere else. It travels 90 miles and the time it took to go that far was 1.5 hours. So its speed is 60 miles per hour. So to calculate speed, you take the total distance you've traveled divided by the time it took. Because speed is a ratio of distance over time, the unit that you're going to have with speed is going to be a distance unit divided by a time unit, okay? Because it's a ratio. So distance or speed can be in meters per second, it can be in kilometers per hour, centimeters per second, miles per hour, but it's always going to be a distance unit divided by a time unit or over a time unit because it's a ratio. Again, how do you calculate speed? Distance divided by time. And guys, you need to write this formula down and you need to memorize it in the next 4 weeks because Ames will expect you to know it and they will not give it to you. Okay? Speed equals distance divided by time. Okay? So that's how you calculate it. So if you said, okay, this bird travels 50 meters in 7.5 seconds, then he's gone 50 meters divided by 7.5 seconds, you divide, he's gone 6.67 meters per second. Notice, it's a distance unit divided by a time unit, so meters per second. So what is velocity? Velocity is the speed something is going, but it's in a certain direction. So whereas speed has nothing to do with what direction you're going in, nobody cares what direction you're going in, velocity is speed in a particular direction. So you can have a positive or a negative velocity, depending on what direction you're going in. And that okay, I know what you're thinking. You're thinking, well, how do I know if the velocity is positive or negative? Well, it's based on the origin. So if an object starts at 0 and goes away, if you go away from the origin, you would have a positive velocity. If you go back towards the origin, you would have a negative velocity. So away from the origin is a positive velocity, back toward the origin is a negative velocity. How do you calculate velocity? Another formula you need to memorize. Velocity equals the final position of the object. X here stands for position. Okay? And it always stands for position in physics. So velocity equals the final position of the object minus where the object started, or the initial position, divided by time. So for instance, our westbound car ended up being 100 kilometers away from its origin. It started 200 kilometers behind the origin. So when you subtract, you get negative 100 kilometers per hour, divided by 1 hour it took to travel. The eastbound car actually ended up 300 kilometers away from where it started. It started at 200 kilometers. You divide by 1 hour and you get 100 kilometers per hour positive. So, westbound car. Let me back up here. I don't know if I explained that exactly right. Westbound car started at 200 kilometers away from the origin, came back towards the origin when now it's 100 kilometers away from the origin. Divided by 1 hour, it's got a negative velocity because it's coming back towards the origin, or where it started. Eastbound car started 200 kilometers away from the origin, ended up being 300 kilometers away from the origin when it finished, took an hour, so it's got a positive velocity. If you don't quite understand this yet, don't freak out. We're going to do lots of examples in class and lots of problems in class. So you might say, Sullivan, this makes no sense. What's the difference between speed and velocity then? They're both taking how far you go and you're dividing by the time. Here's the difference. Let's say I start at this crossroad right here, at this little point where my mouse is pointing, and I start walking this direction. And I walk 10 miles this way, and I walk, well, let's put me in a car because that makes it more realistic because it's only going to take me an hour. So let's say I'm in a car, and I start right here, and I drive 10 miles this way, and then I turn and I drive 15 miles this way, and then I turn and I drive 20 miles this way, and then I turn and I drive 15 miles back up to where I started, and then I go 5 miles farther than that. You might say, Sullivan, that makes no sense. Come on. Okay, well, let me give you a scenario. I start off at my house. I drive 10 miles this way to the grocery store. I pick up some peanut butter. I love peanut butter. Then I drive 15 miles this way to the Hobby Lobby, where I pick up some material to make my dog a dog bed, because I love my dog. Then I drive 20 miles back this way, and I stop at Walmart, and I buy myself a new shirt, because I deserve it. And then I decide I'm going to take all my stuff home, back home. So I drive 15 miles this way and I go back home. And I drop off my stuff. And then I drive 5 miles to my mom's house to eat dinner. Okay, so that's what I do. My speed would require that I add up all the distance that I traveled, all of it, and I divide by the time it took me to do it. So let's say it took me an hour to drive all those places and come back to my mom's house. I know I'm speedy. Okay. So for speed, I add up all the distances, 10 plus 15 plus 20 plus 15 plus 5. I get 65 miles. I went 65 miles. And I divide by the time it took me. So here, speed equals total distance divided by time. So 65 miles. And I divide by 1 hour. And my speed would be 65 miles per hour. That was my speed over the whole trip. Now my velocity, though, is going to be where I ended up at my mom's house, subtract where I started from. So my house. So that distance, if you take from here and you subtract here, that distance, the total distance I went there, I only ended up 5 miles away from my starting point. So my velocity would be 5 miles divided by 1 hour. I went 5 miles per hour. Even though I drove all the way over here to the grocery store, and then I drove all the way down here to the Hobby Lobby, and I drove all the way over here to the Walmart, and I drove all the way home and then out to my mom's house, even though I went all that way, my velocity, all I care about is where did I end up and where did I start from. So I ended up 5 miles away from where I started from, which was my house. So my velocity is 5 divided by 1 hour. It took me an hour to do it. 5 miles per hour. My speed, I care about the total distance I drove. So I add up all these distances for my speed and divide by 1 hour. For my velocity, I just care about where did I end up and where did I start. That is the difference between speed and velocity. Speed is the total picture. Velocity, all I care about is where did I end up and where did I start from. If I drove 87,000 miles in between all different directions, I don't care. All I care about is where did I end up, where did I start from, and divide by the time. That's the difference. So real quick, what is acceleration? Acceleration is a change in velocity over time. The easiest way to remember acceleration is to think about either speeding up or slowing down. Okay? So let's say I'm driving and I'm going to get on the freeway. If I'm going to get on the freeway and I'm at a stop sign, I'm going to speed up real fast to get on the freeway. Okay? That would mean I was accelerating. That would be positive acceleration because I'm speeding up. Now, let's say I drive on the freeway for a while and I stay a constant speed. I go 65 miles per hour the whole time. And then I decide I'm going to get off the freeway. When I get off the freeway, I'm going to have to slow down to stop at the light at the end of the road. So I'm going to start slowing down. That's called negative acceleration. We also call it deceleration when I slow down. Okay? So acceleration is speeding up or slowing down. You need to write down this formula and memorize it as well. Acceleration is my final velocity, how fast am I going at the end, minus my initial velocity divided by the time it took me between the two, to go between the two. That's acceleration. So again, when I'm speeding up onto the freeway, let's say my final velocity is 65 miles per hour. My initial velocity is 0 miles per hour because I started at a stop sign. So 65 minus 0 would be 65, and then divide by however long it took me to do that. Let's say it took me 6.5 seconds. That means I'm going 10 miles per hour. I'm accelerating at a rate of 10 miles per hour. When I'm slowing down getting off the freeway, I start at 65, or I finish at 0 miles per hour because I stop at the stoplight. I started at 65 miles per hour, so that's negative 65. And my time, let's say again, it's 6.5 seconds. So I'm going actually then miles per second negative. So it'll be a negative number, so I'm slowing down. So acceleration, if it's positive, it means you're speeding up. If it's negative, it means you're slowing down. Again, if you don't quite get it, just make sure you get the formula down and you get down that acceleration is speeding up or slowing down, positive or negative, and we're going to do all kinds of examples in class. So in closing, speed is the total distance you travel, all added together no matter what direction you go in, divided by the amount of time it took. Velocity is the change in distance you went from your starting point. So it doesn't matter what directions you drive in, it's how far you end up from your starting point, divided by the total time it took. Acceleration is a change in velocity. It's how fast you're going at the end minus how fast you're going at the beginning divided by the time it took. So it's either speeding up or slowing down. Have a good day.